So this is January 10th, Monday. I just want to go over the review questions that we did last Thursday. Friday, you had a graded assignment on them, so you'll need to make that up if you missed it. In period 2, there are 8 elements. You can get that by looking at the periodic table. Remember, periods are horizontal, groups are vertical. So groups go up and down like this. Periods go across the paper. Remember, you write across the paper and then you put a period at the end. Groups 18 or period 18, period 4 has 18 elements. 6 period has 32 elements. Right? And then here they gave you the name of the element. You had to say what block it was in. So rubidium is in the S block. All right. So as a reminder, remember, this is your S block over here. See, this one's color coded. So this is the S block, this is the P block, this is the D block, and this is the F block down here. Okay? And okay, so you just had to find the element and say what period it was in. All right, number 3. Group 17 is the halogens. I will expect you to know these, by the way. Group 1, Group 2, Group 17, Group 18, and lanthanides and the actinides. I will expect you to know these by group number. If I ask you which element in Group 1 is in period 3, you should be able to tell me. All right, just on that description. Now, you'll get a periodic table. I don't expect you to memorize the entire periodic table, but you should know that group 1 is the alkali metals, group 2 is the alkaline earth metals, group 17 is the halogens, group 18 are the noble gases. Group 1, aka the alkali metals, are the most reactive metals. Group 17, aka the halogens, are the most reactive non-metals. Okay, so if you put a alkali metal and a halogen together, they're very reactive together. Group 16, the outermost S and P sublevels are completely filled with electrons. As a result, noble gases do not need to form chemical bonds. So here's the thing. If we look over here, all right, here's the S orbitals, or the S block. Here's the P block. So if we look at hydrogen and helium, helium is a noble gas. It's over here because it's part of the S block. If we look at the regular periodic table based on properties, then helium is a noble gas. But when we're talking about electron configuration, it's part of the S block. All right, so 1s1, 1s2. So helium has a full outer shell. So if we click on that, we see it has a full block. We look at neon, has the 1s shell full, 2s full, and the 2p is full. So this tells us two things. One, the S block and the P block are your valence electrons. Okay? Even if the electron configuration has other stuff in it like D's and F's, the S block and the P block are your valence electrons. It also tells us that every noble gas has a full outer S and P block. So they don't need to gain, lose, or share electrons to have a full outer S and P block. If we look at argon, okay, 3s is full, 3p is full. We look at krypton, okay, the 4s and the 4p are full. We look at xenon, the 5s and the 5p are full. Radon, 6s, 6p, full. Oganesson, okay, 7s and 7p, full. Okay, so they don't need to gain, lose, or share electrons because they are ready to go. All right. Now, let's see here. Where was I? Group 7. So the question for number 6 was, why are the noble gases so stable? And that's why. Because their S and P sublevels are full. The representative elements are groups 1, 2, 13, 14, 15, 16, 17, 18. Okay. Common name for the D block is transition elements or transition metals. Some textbooks say transition elements, some textbooks say transition metals. Okay, just did those. Number 9, right? Based on, you were given this description and you had to write the electron configuration. So element in period 2, group 15 would have this configuration. Element alkaline earth metal, so that means it's in group 2 in period 3 would have this configuration. Noble gas in period 3 would have this configuration. Right? These are the kinds of questions that I might ask you, and that way I can tell whether or not you know alkaline earth metal is group 2, noble gases are group 18, so forth and so on. Same thing with questions like this. Halogen, period 5, that'd be iodine. Alkaline metal in period 4, potassium. Period 4 has 2 electrons in the p sublevel. Right? It's germanium. Period 2 with 6 valence electrons, oxygen. Lanthanide with 3f sublevel electrons. That's praseodymium. I don't know if I said that right or not. All right, but let's look at these two real quick. Period 2, 6 valence electrons. All right, so if we look at the periodic table and we go to period 2, all right, this has 1 valence electron, 2 valence electrons, 3, 4, 5, 6. So that's oxygen, right? That's all you had to do. All right, if we look at, oops, I clicked on the wrong thing. Lanthanide with 3f sublevels. Okay, so lanthanides are down here, right? These are the lanthanides. So we have the 6s1, 6s2, and then we have the 4f1, 2, 3. So that's the praseodymium. All right. Period 6 with 5 half-filled d orbitals. Now the d orbital can hold 10 electrons, right? So if they're half-filled, that means there's only 5 electrons. So again, we go back to our periodic table, and let's see, what was that? Period 6, half-filled. Period 6, half-filled. So here's period 6, okay? And so we have 1, 2. Now we got to count lanthanium. 1, 2, 3, 4, 5. So the answer is rhenium. Okay. Number 11, indium has 5 occupied principal energy levels and chemical properties that are similar to gallium. Because they're in the same group, elements in the same group have similar properties. All right. Number 12, you had to look at the electron configuration and say what group it was in, what period it's in, what block it's in, how many valence electrons, the name, and the type of element. All right. So if we look at this, all right, the highest number here is 4, so it's in period 4. All right. There are 8 valence electrons, so that means it's in group 18. It has a P block, right, because it's in 4p6. It has 8 valence electrons because the S and P are your valence electrons. It's krypton and it's a non-metal. Remember, on periodic table, all this stuff, metals. Oops, let me move this out of the way. All right. Everything over here are the non-metals. Hydrogen and helium are also non-metals. All right, so we got non-metals, and then everything on that stair step, those are the metalloids. All right. All right, 5s1, so we know it's in period 5. We know it has 1 valence electron. We know it's in the D block because it's in period 5. Well, no, because you have 6 plus 1, that's 7, so it's in group 7. So it's in the D block. It's technetium. Remember, this sort of question you should be able to do it without a periodic table. I realize you can look at the configuration and figure out the name of it, but you're supposed to be able to do these types of questions without the periodic table. All right, so 2s2, 2p1. So it's in period 2, right, because that's the highest number. It's in group 13. And it's in the p block, has 3 valence electrons, and it is boron. Okay. D, all right, it's in period 6 because that's the high number there. It's in the F block, so it has no group. 2 valence electrons, so this is diprosium. All right, and then E, it's in period 6 in group 5, so the outer 2 here, so that's 3 and 2, that's 5, so that's in group 5. D block has 2 valence electrons, it's tantalum, and it's a metal. This is period 3, group 1. It's in the S block, right? S block has 1 valence electron because there's a 1 right there, and it's sodium, and it's a metal. All right, so that's the review questions. Now, let's take a quick look at the graded classwork you did. That's not it. There we go. All right. So period 3 has 8 elements. The 6p orbitals begin in period 6. That's why it says 6p. Number 3 is false. Number 4, 3s and 3p sublevels are being filled in the 3rd period. True. The 3rd period of the periodic table only has s and p sublevels. Number 5 is true. Number 6 is true. So right, there's a 6 here. So that tells you it's in the 6th period. Element is found in period 4, and that element is manganese. Well, if you look up element number 25, you'll see that it is in period 4. So that's true. D sublevel is always 1 energy level behind. So if we look at the periodic table, this is the 4th principal energy level, right? Or 4th period. This is 3D, right? And actually, if we take and we go white here, oops, okay, so we can actually, like, this is 5s, this is 4d, 5p, then we have 6s, 4f, 5d, 6p, 7s, 5f, 6d, and then 7p. Okay. So the 4f belongs in the 6th. Okay. Because remember, the f's are 2 behind. So 4f would be in the 6th period. Number 9 is true. With the exception of helium, all s and p levels, all s sublevels are in groups 1 and 2. Number 10 is false. That should be 3 through 12, not 4 through 9. Number 11, the f orbitals are primarily filled in periods 6 and 7. Number of valence electrons in the p block. To find that out, you would take the group number minus 10. So, for example, like this is group 15. So 15 minus 10 is 5. Everything in group 15 has 5 valence electrons. Group 17, 17 minus 10 is 7. Everything in group 17 has 7 valence electrons. Alkaline earth metals have blank valence electrons. Okay, they have 2. Everything in group 2 has 2 valence electrons. Everything in group 1 has 1 valence electrons. Strontium has that configuration, so that is true. It has 2 valence electrons. That's the 2 right there. Noble gases, this should be a 6. It should be S2P6 for noble gases. Polonium has the electron configuration Hg6P4, which gives it 4 valence electrons. Oxygen is in group blank and has 6 electrons. Well, remember, oxygen is in the P block, so 16 minus 10 is 6, so that works out. All right, oxygen is in group 16. If you thought it was 13, 13 minus 10 is 3. Oxygen has 6 valence electrons, not 3, so that can't be the answer. Iron has the configuration of this, putting it in group 2. No. Iron has electron configuration. That should be 8. That was the wrong answer. And my honors kids didn't catch that either. Alright, so we look at the periodic table. There's iron. It's in group 8. Halogens are found in group 17. Period 4, group 1. Potassium. True or false? Radon is a noble gas. That is true. Atomic number 34 is halogen. Well, there is a halogen. So we find element 34. Nope, that's in group 16. That is not a halogen at all. So that is false. Right? Radium is located in group 2 and is considered to be a blank metal. So we find radium. Radium's right there. It's in group 2. So it's in group 2. So that's an alkaline earth metal. Transition element 28 Ni. So the 28, that's actually supposed to be a subscript. That's the atomic number of nickel. So we find nickel, it's element number 28. It's right there. It's in group 10 in period 1, 2, 3, 4. Period 4. Okay. So it's in group, I forgot what I said. It's group 10. Oops. That's not what I want to do. That is. Actinides are all located in group. The answer is 3. No group would also be acceptable, I think. But they're considered group 3 because when you look at the periodic table like this, okay, that's where they show up, right? Tungsten, atomic number 74, is a transition element. So we find element number 74, and that is in fact a transition element. So that is true. Lanthanide element samarium, atomic number 62, is found in group 4. Is that true or false? So we find element number 62, and 62 would be in period 6 because it's a lanthanide. It is a lanthanide. It's in period 6, so that's false. All right, and that's it. All right, so I hope this helps you study. Your midterm will be on the 18th. It will cover everything from the first day of school to the end of the periodic table chapter. All right, have a good day. I hope this helps you study. Oops, there's my... Uh-oh. There we go.